Hello friends, now we calculating what is the potential energy of a 3-point charge system. Potential energy of 3-point charge system. For that, suppose we have a 3-point charges assembled like this way. This is charge Q1, charge Q2, which are separated by a small distance R12. This is the position of third charge, that is Q3, which is at a distance R13 from Q1 and at a distance R23 from Q2. Can name as this point is A, B and C. Now, by definition of potential energy, is the total work required to bring the charges from infinity to their location. Total work required to bring the charges from infinity to this point and assemble like this way. So, first we are finding what is the work required to bring Q1. But you see, no work is required to bring Q1. Why? Because at this location, no other charges. Is it? Initially, we have no other charges in this site. And first, we are bringing Q1 to here. So, no work is required because this is a field-free region. In this region, there is no electric field and potential. So, we are finding what is the work required to bring Q1. That's you writing as W1. W1 is equal to 0. Work required to bring Q1 is equal to 0. That's 0 as W1 is equal to 0. In this region, there is no other external electric field. W1 is equal to 0. What is W1? W1 is the work required to bring Q1. That's we writing as W1. What is W1? Is equal to 0 because there is no external electric field. Now Q1 is brought here. We are bringing Q1 from infinity and placed at the point A. Now we are bringing the second charge Q2. But at the point B, there is a potential. Potential due to Q1. Q1 produce a potential at B. So some work should be done to bring Q2. So what is that? Work required to bring, what is that? Work required to bring Q2. That's we writing as W2. Work required to bring Q2 is equal to, what is that? Q2 is equal to potential at this point into Q2. Charge into, is it? Charge Q2 into potential. What is potential at B? Potential at B is potential due to Q1. What is that? Potential due to Q1 is 1 by 4 pi epsilon 0, 1 by 4 pi epsilon 0 into 1 by 4 pi epsilon 0 into Q1 by distance to this point. What is distance to the point? R12. Or we can write like this way. This is equal to 1 by 4 pi epsilon 0 Q1 Q2 by R12. That is W2. 1 by 4 pi epsilon 0 Q1 Q2 by R12. We brought Q2. We brought Q2 from infinity to this point. Now we are bringing the charge Q3 to this point C from infinity. We already brought Q1 and Q2 and placed at A and B. Now at this point C, there are potential due to Q1 and Q2. That's it. So now if you are calculating what is the work required to bring Q3, that is work required. What is work required to bring Q3? That can be write as W3. What is that? That's equal to charge into the total potential at C. What's the total potential at C? Potential due to charge at A plus potential due to charge at B. What are they? Potential at C is equal to 1 by 4 pi epsilon 0. First we are finding potential due to Q1. That's equal to Q1 by distance to that point is what? What is distance between Q1 and Q3? R13 plus this charge also producing potential at C, that is equal to Q1 by 4 pi epsilon 0 Q2 by R23. That is potential due to Q2 at a point C. Now we are writing that W3 as 1 by 4 pi epsilon 0 Q1 Q3 by R13 plus 1 by, we are multiplying by Q3, 1 by 4 pi epsilon 0 Q2 Q3 by R23. This is W3. By definition, the total work done to bring or assemble these charges stored as potential energy. So we can write as potential energy of the system of charge U is equal to W1 plus W2 plus W3. W1 plus W2 plus W3. What is W1? Substitute the value. W1 is equal to 0 plus what is W2? W2 is equal to 1 by 4 pi epsilon 0 Q1 Q2 by R12 plus what is W3? W3 is 1 by 4 pi epsilon 0 Q1 Q3 by R13 plus 1 by 4 pi epsilon 0 Q2 Q3 by R23. This is the potential energy of this 3-point charge system. If you want, can rewrite like this way, keeping 1 by 4 pi epsilon 0 as constant, and inside this bracket Q1 Q2 by R12 plus Q1 Q3 by R13 plus Q2 Q3 by R23. So this is the potential energy of this system. Similarly, you can find the potential energy of a 4-point charge system, or whatever may be the number of charges, no problem, as potential is algebraic. Following the algebraic addition, you can find the potential energy of any number of system of charges. Thank you.